Well, hello everyone. This is KP, the Math G, once again. Whoops, wrong side of the board. We'll look at that side later. That's the side we're looking for. And as I said before, especially if you were on the last video, and if you weren't, we are dealing with the 2011 free response question number 2, and it has to do with T being the temperature of T going down as the time goes further and further from 0 to 10, as we can tell. So it says as a pot of tea cools, the temperature of the tea is modeled by the differential equation H, for which T is between, including 0 and 10. And that's going to be in minutes. We're going to skip 1 and 2. I think you can, A and B rather. I would talk about that a little bit more in detail, other than the fact that B is that when you see this, and I'm going to go ahead and just kind of set it up, and I'm not going to do anything to it, but anyway, it says interpret or evaluate, or what does it say? Explain the meaning. Alright, well, when you see that right there, alright, and H of T dt, okay, like that, what is that? That is the average something, right? Alright, it's the average. In this case, we're talking about average temperature. This is the average temperature. You see this right here, this setup just like this, you're going to see average temperature. Alright, that's it. Alright, and they go on to say, figure this out by the trapezoidal rule, and I'm not going to worry about that at that point, because well, for one reason, if you want me to do that in another video, I will. I've got other videos where I've showed this, so somewhere out of 120 videos that I've given, it's in there. You should find something probably 2 or 3 times in there that have to deal with that very thing. Okay, so getting back to part C, we're just doing C and D of this one. It says as a pot of tea cools, the temperature of the tea is modeled by the differential equation function H, for which T is between 0 and 10. Evaluate this. Now, you know what this is, don't you? H prime at T, and then you're integrating from 0 to 10. You got an integrand from 0 to 10, and then you're taking you're integrating the derivative, right? So what is that? Well, it's simply this. If you answered that it is the fundamental theorem of the calculus, part A or B, part 1 or 2, you are correct. It is H at 10 minus H at 0. Alright, that's all that is. And H at 10 is 33. H at 0 is 66. So we have a negative 33. Actually, 40. This should have been a 43. I don't know why I put 33. That should have been a 43, my bad. I just have to put it in purple. So I should have known that didn't look right. But anyway, now that's negative 23 degrees Celsius. So what can you conclude? The conclusion is the temperature of the tea, and you can say dropped. Now, do not make a mistake and say this. Do not, that's supposed to be a negative. do not say negative there. It's dropped. There's your negative sign right there. Okay, from, and then you can put the, okay, you can put that there like that. Okay, t between 0 and 10. Alright, and alright, so you can, they say from time t equals 0 to time t equals 10 minutes. Yeah, they do have it in minutes. Okay, there it is. Or maybe on the interval, you can say anything like that, but the temperature of the T dropped, and of course in your answer, you do want to have the negative sign. Okay, like that. Alright, there it is. Obviously this is a decreasing function here. It's going to drop. Temperature is going to drop. You take, you cool T off, it's going to drop so much, right? So there it is. Alright, there's that part right there. It should be fairly simple to do. But you know what? I had trouble with this before. I had to figure out what this thing here meant. It's this here. Okay, and that's what you got to go by there. Alright. Here is D part. Let's see this thing over. Okay. Just gotta lose a little weight, don't I? I am losing some. Doesn't look like that just yet, but hopefully one day. It won't take me 2 years for it to look way down, but I'm hoping for better than that even. But anyway. At time t equals 0, biscuits are removed from the oven at 100 degrees Celsius. Now these biscuits are going to cool off, aren't they? The temperature at time t is modeled by. Now here's something you got to look at. This b whatever, this function b at 0 is equal to 100, and that's what you got to remember. Initially it's 100 degrees Celsius. Okay, so that is initially right there. Keep that kind of stuff in mind. It's not always going to begin at 0. It may, you know, like it may be like, in other words, you're giving Johnny 100 feet head start. Okay, a 100-foot head start. They're already 100 feet in front of the starting line. You see what I'm talking about? Okay, not everybody starts at the same place. Well, when biscuits are cooked, they're going to have a temperature already, so it's already 100 degrees Celsius. Temperature at time t is modeled by the differential of function b, for which b prime, or it has been seen that b prime at t is equal to negative 13.84 e to the negative 0.173 t. I tell you what, the people who make up this, that's really amazing right there. They're really good. Alright, using the given models at t equals 10, how much cooler are the biscuits than the t? Alright, so we're talking about temperature here. This is a rate, so we have to integrate that rate to get back to the temperature. See, the temperature is modeled by b. We want to get back. This is just a practice of the fundamental theorem of the calculus, isn't it? Okay, so actually, here's how we set it up. If you already guessed 100 plus, you are doing well. Okay, make sure that you understand that you do that. Alright, and then you are going from time 0 to 10, b prime at t dt. Now we just got to plug that in. Now what I did, I got to y vars. I think some of you get to vars and then you get to y vars. Alright, But I mean, after I put it in, I'm sorry, I put in y equals, and I got a y sub 0 equals, and I put this in there right here. Okay, the whole thing. Okay. And then of course on mine I don't get t, but I get x, so it doesn't matter anyway. You do that right there first, and then if you can get to 100 plus integrating from 0 to 10, and then you call up y vars. Okay, y vars, and then it's going to come up with a screen, y0, y1, y2, etc. You choose y0. In my case it's in y0. So y sub 0, d, and in this case it'd be x, like that. And that's all you really, if you can learn to do that, you're going to save yourself a ton of time. Now if you want to go ahead and plug this in and just if you don't think about this, just think to put this all in there like this, and then the dx there at the end. Of course we know it's dt. Okay, then you should get an answer when you hit that equal sign of 8.8173. Now 8.817 is what they have. 8.817. Now that is in degrees Celsius. Alright. Now what we have to realize is, though, is that that's not our final answer. Be very careful with that. That's not your final answer. So what you got to do is, it says how much cooler are the biscuits than the tea. Well, this is how cool the biscuits are. Okay, the tea is, well, let's see here. The tea at 10, it's 43. Okay, for some reason or another, that should be it though. Let me see. What did I do here? Yep, that's what I got. That is it. Okay. Alright, so 8.817. Okay, there it is right there. Okay, so I'm just trying to think. Okay, at time t equals 10, how much cooler are the biscuits than the tea? Alright, the biscuits are 8.817 degrees cooler than the tea. Alright, now wait a minute now. Let me see what's going on here. Well, alright, so wait, I know what I did wrong. Okay, that is not it. That's the final answer. This answer is, my bad, I tell you. You know, I may be 63 years old, and I'm not yet senile, although sometimes it seems like it. I'm not there yet, and that's the key word, yet. Please forgive me. And I was looking at the calculator wrong, all wrong. I knew something was wrong here. I was looking at the final answer. This is the answer. Alright, like this. Now, that's better, isn't it? I seem to say. That's this answer to this. This is how much it's cooled down, okay, from 100 degrees Celsius to now at t equals 10, 34.183. Alright, so now we go back to our table. Alright, 34.183. Alright, we know that's 43 here. Alright, so that's the t here. So 43 minus, back to 43. Alright, t at 10 is 43. So that's what we wanted to do. It's going to be h at 10 minus b at 10. And that's going to be 43 degrees Celsius minus 34.183 degrees Celsius, and then you do get your final answer. Alright, so that's going to be, let's just put it over here. Okay, you see how much room I have, which is very little. Okay, alright, the final answer right here is 8.8. That's it. 8.8173. I knew something didn't look right. And that's how much cooler the biscuits are, that the tea is, than the biscuits. Alright, well actually the biscuits are cooler than the tea. Alright, yeah, that's right. Yeah, the tea's a little hotter. Alright, that's the tea, that's the biscuits. So the biscuits are, yeah. Alright, so you might want to say the biscuits are this amount cooler. Alright, 8.817 degrees Celsius cooler than the tea. Alright. Alright, that's it right there. Now I knew I was just looking at this all wrong. I apologize. I have both answers on my calculator, which is really on my phone. Alright, so that's it right there. I knew something didn't look right. So what you're doing, once again, one more time, just to make sure we have that, at t equals 10, the temperature of the biscuits is 43 of the tea, not the biscuits. The biscuits are, at time t equals 10, by that 10th minute, that's down to 34.183, from 100 to 34.183, so you subtract those two off, and that's your final answer. And that's what you got to remember. This is not your final answer here. That's good if you found that, but then you got to come and subtract this off right here. Alright, so h at 10 minus b at 10. That's what you have there, and that's what we have to do. Okay, well, finally we got it. But these are kind of things that you need to kind of keep in mind here. Sometimes we get an answer and we think we've got it. That's not it. You got to remember the question asked, well, how much cooler are the biscuits than the tea? Well, there it is. That's the final answer there. You got to be really careful with that. Okay. I hope this has helped you out. I hope this is helping you. This is, I want to say, the 122nd video right here, and I'm planning on doing another one. I want to say I'll be still on the 2011 free response. I want to say I'm going to look at, I don't know if it's question 3 or 4 or 5. I don't remember now which one it is, what order I'm doing this in. Let me look. I think I do have my papers with me. We could probably get into question 3 next time, but I do want questions 3 and question 5 and question 6. And if you want me to do question 4, I'll do that as well. But anyway, I just wanted to get into those particular questions, and I'm trying to do questions that I have not presented. I haven't presented that type before, so I just want to make sure that before you take your test, and please, students, if you are in the AP class, I know you're seniors. If you have not taken this test yet, please take it seriously. These teachers have gone through an entire year of trying to train you and get you ready for this test. So take them seriously and do the very best that you can. Sprint across that finish line. Don't just, well, I've got my grade in the class and that's it. So do the best that you can on these tests. They've gone through it for the entire year, and so just give them your best too on that test, and give yourself, do it for you too. All right, and I know you will. All right. Well, anyway, KP the Math G, about ready to sign off. I'm getting ready to work out again today. And we had some outdoor things that we're doing with garden and trying to grow quite a few plants and vegetables and flowers. My wife does the flowers. Anyway, KP the Math G, about ready to sign off here. Make sure you hit that subscribe button if you haven't already. Make a comment if you would like to, and hit that like button. That really puts a big smile on my face to see that like button. But at any rate, no matter what, I hope you get something out of this. That's what I'm here for, is to help you get something out of this, whether you hit that like button or not, or subscribe or not. KP the Math G signing off. Ladies and gentlemen, have a great, great day.